Welcome to the first of a set of videos, I hope, for linear algebra. I'm going to try to do one of these videos for each section, though some of them might be longer than others, and some of them I may end up breaking up. This is designed to go with what's in the textbook, so you use the textbook as a reference, and then hopefully I'll do some examples here, maybe that aren't in the textbook, or just to start explaining some basic concepts. So systems of linear equations is probably not shocking to you. I bet you did that somewhere in high school Algebra 1 or high school Algebra 2. We're going to look at them a little bit differently. First of all, you realize what is linear. Something like y equals mx plus b. Y equals mx plus b is linear, whereas something like y equals e to the x is not linear. So when we talk about linear versus not linear, those are the types of things we're talking about. We can write equations for linear systems. So for example, you might have the equation of a plane, right? X plus 3y plus 2z equals 4. But sometimes in a course like this, rather than use x's and y's and z's, we use variables with subscripts. So I might write something like x sub 1 plus 3 times x sub 2 plus 2 times x sub 3 equals 4. And by sub, I'm talking about those subscripts, x sub 1, x sub 2, x sub 3. So maybe we want to arrange these things into a system with coefficients and variables. So suppose I have an equation that looks like this. I'm going to call this a sub 1, 1, x sub 1. And then we'll do it for the 2's, and then we'll do it for the 3's also. So I'll make this a 3 by 3 system. So a sub 1, 1, x sub 1 plus a 1, 2, x sub 2 plus a 1, 3, x sub 3 equals some constant. Let's call it b sub 1. Now, maybe you start to see where I'm going with these 1, 1's and 1, 2's. Let's write out a couple of more rows, and then we'll see where this is heading. I've got an a 2, 1, x sub 1. I've got an a 2, 2, x sub 2. I've got an a 2, 3, x sub 3. And I'll call the constant on the other side b sub 2. And then for this one, I'll use a sub 3, 1, x sub 1. I've got a sub 3, 2, x sub 2, and I've got a sub 3, 3, x sub 3 equals b sub 3. So what I'm really doing with what we call our a sub ij's is that I is the row, rows go left and right, and j is the column. Right? Columns hold up a building. So if you're holding up a building, those columns better go top to bottom like that. So if you look at my subscripts here, this is row 1, column 1. This is the coefficient that's in row 1, column 2. This is the coefficient that's in row 1, column 3. You'll notice that the variables go down by column. So this is the column that has all the x sub 1's. That's the column that has all the x sub 2's. That's the column that has all the x sub 3's. And then on the other side of the equal sign are all the constants. Now, you can review ways of solving systems of two variables and two equations. You can do elimination, you can do substitution, you can even graph them. When you graph the two lines, the place where they intersect is the solution. There's, of course, special cases, right? Two lines that are parallel to each other will never intersect. So if you have equations of lines that are parallel to each other, then they simply won't have a solution. In the same way, if you have a three-variable system like this, if you have two planes that don't intersect, then they won't have a solution. So let's look at a system that looks like this. All right. For years, I've gotten used to putting curly brackets around my systems. Some people don't do that anymore. Some do. So if I switch back into putting those things around, that's just what they mean. That means that all the equations are associated with each other into a system. So let's say I've got this equation, x sub 1 minus 3x sub 2 plus x sub 3 equals 8. Then I'll add a couple of more. I'll add an x sub 2 plus 3x sub 3 equals 5. And then I've got x sub 3 equals 2. All right. There's a name for this form. We call this row echelon form. Sometimes you'll also see this referred to as having a stair-step pattern. So you've got the x sub 3, then the next row has two variables, and the third row on top has all three variables. And you can solve this system easily by what we call back substitution. And back substitution is just what it sounds like. If you want to find out values for all three variables, well, you already have x sub 3, then you substitute it back into the line above it. So you can substitute x sub 2 plus 3 times the value that we have for x sub 3 equals 5. Subtract the 6 from both sides, and x sub 2 is equal to negative 1. Now that you have that, you can go back to the first row and say x sub 1 minus 3 times negative 1 plus 2 is equal to 8. All right, so that makes a 3 plus 2 is 5. So subtract a 5 from both sides, and I get x sub 1 is 3. So I can represent my answer as an ordered triple, right? If I was in 2 dimensions, I'd have an ordered pair. In 3 dimensions, I have an ordered triple. I put x sub 1 first, then I put x sub 2, then I put x sub 3, and that's my answer. Sometimes you might write it as x sub 1 equals x sub 2, x sub 3, but I'm going to write it as an ordered triple. So when you have a system of equations like this, you can create what we call equivalent systems. And when you create an equivalent system, there's 3 things that you can do without changing the value of the system or the solution. And I'm not going to always write everything out, but I think this one is important because it's going to show up over and over and over. So there's 3 things that you can do that will create equivalent systems. The first thing is you can interchange 2 rows. So in my example above, I could have switched row 2 and row 3. I could have put the one with 3 equations down the bottom and the one with 2 equations at the top, and it wouldn't have made a difference. I would have still gotten the same solution. So I can interchange 2 rows. I can multiply an equation by a non-zero constant. So multiply 1 row by a non-zero constant. Of course, if I multiply by 0, the whole thing goes away, and that changes the meaning. But suppose in my equation above I had decided to multiply the entire middle row by negative 5. Wouldn't have made a difference. When I went to go substitute back, I would have still gotten the same answer. And then the third thing that I can do is I can add a multiple of one row to another. In our case, we didn't have to, but we will eventually. Okay, so those are the 3 things I can do without changing the equation, without altering the system. It'll still have the same solution. We'll eventually get to the point we call these elementary row operations. But not yet, because it's the first video on the first day. All right, so let's take a look at a system of 3 equations and 3 unknowns and see if we can come up with a solution by eventually writing it in row echelon form. So let's start by writing out the system like this. I've got 2x sub 1 plus x sub 2 plus 4x sub 3 equals negative 3. I've got 3x sub 1 minus 2x sub 2 minus 3x sub 3 equals 5. And then down here I've got x sub 1 plus 2x sub 2 plus 2x sub 3 equals 6. And I would like to solve this. Now, when I do this, I'm going to work through a process of getting rid of variables so that I end up with that same stair-step form that I had last time. So what is it that I'm trying to get rid of? I'm trying to get rid of the x sub 1s over here and the x sub 2 over here, right? If I can do that, then I'll have that stair-step form where I have an x sub 3, an x sub 2, and an x sub 3, and then 1, 2, and 3 on the top. My suggestion is work through this in some sort of process. I know it looks tempting to say, well, look, I can combine a couple of x sub 2 that's over here, combine them, and I'll get 0. And yeah, sometimes it works nicely, but sometimes what happens is you end up going back and reinserting values that you had gotten rid of, and then you end up in this cycle that you just can't stop. So let's try to figure out some process that will get rid of those x sub 1s first. So the first step that I'm going to do, and you could write out all your steps at the beginning, after a while this will become a much easier process. Let's take equation 2. All right, that's that middle one, and subtract 3 times equation 3. Now when I do this, I'm also going to want to figure out where to put it. So I'm going to want to drop everything down into the 3rd spot. All right, the first time I'm going to write all this out. What does it mean to take equation 2, subtract 3 times equation 3, and put my answer in equation 3? First of all, the first row doesn't change, so I'm not going to spend the time recopying that first row. All right, if I take equation 2, that's going to give me a 3x sub 1 minus 2x sub 2 minus 3x sub 3 equals 5. We said we were going to multiply the third row by negative 3. So now I get negative 3x sub 1. Take that 2 and multiply it by negative 3, and I get negative 6x sub 2. Take that 2 and multiply it by negative 3. We get negative 6x sub 3. Don't forget the other side. 6 times negative 3 is negative 18. Now, combine these two things together. The x sub 1's cancel. I end up with negative 8x sub 2 minus 9x sub 3 equals negative 13. We said we're going to put that in the spot for equation 3, so let's do that. Let's recopy what I have. I'll try to stick it in the side here. So I got 2x sub 1 plus x sub 2 plus 4x sub 3 equals negative 3. The second row didn't change, right? So I got 3x sub 1 minus 2x sub 2 minus 3x sub 3 equals 5. And now I'm going to replace the third row with this guy down here. So I've got negative 8x sub 2 minus 9x sub 3 equals negative 13. So I've created a 0, essentially, in this bottom left corner here. Now, what can I do to get rid of that 3 that's up on top? Well, I'm going to have to do something between row 1 and row 2. So if I take negative 3 times equation 1, and I add it to 2 times equation 2, put that answer in the spot where equation 2 is, I'll have gotten rid of that 3 up there. That's my goal. Doesn't have to work that way. I could put the negative in the second and the positive in the first, just as long as I'm creating zeros. So what does this look like? Well, if I multiply equation 1 by negative 3, I get negative 6x sub 1, negative 3x sub 2. 4 times negative 3 is negative 12. And negative 3 times negative 3 is positive 9. All right, look at the second row. I'm going to multiply that by 2. So I get 6x sub 1. I get minus 4x sub 2. I get minus 6x sub 3. And then 5 times 2 is 10. All right. What goes away? Just what we want goes away. That x sub 1 goes away. I get negative 7x sub 2 minus 18x sub 3 equals 19. All right, and we said that goes in the spot for equation 2. So we're going to have to move this up a little bit. Let's rewrite our line 1, which is 2x sub 1 plus x sub 2 plus 4x sub 3 equals negative 3. Okay. Now we know what we're going to put in for line 2. We're going to put this guy in here for line 2. So negative 7x sub 2 minus 18x sub 3 equals 19. And then we know what to put in for our line 3. Negative 8x sub 2 minus 9x sub 3 equals negative 13. All right. So there is my system. I've gotten rid of the 2 entries that were in the first column. Now I'd like to get rid of the x sub 2 that's at the bottom over here. Right? I want to get rid of that. Now, this is going to be admittedly a little bit messier because I've got a negative 7 and a negative 8, and the only thing that will get rid of them, the least common multiple. It's been a while since you've heard that word before. The least common multiple of those two is a 56. So if I multiply the top row by 8 and the bottom row by negative 7, that will get rid of that guy down there. So what am I doing? I'm doing 8 times equation 2 minus 7 times equation 3, and I'm putting my answer in equation 3. I think it really helps if you sort of write yourself a map like that first so that you know where the answer goes when you get done, because there's a lot of equations and a lot of variables. Let's come along the side over here and try that out. I may at some point decide to grab a calculator when the numbers get big. 8 times negative 7 is negative 56. So I get negative 56x sub 2. 8 times 18 ends with a 4. That much I got. 144. So 8 times negative 18 is negative 144. And then on the other side, 19 times 8 is 152. Okay. Is it a positive or is it a negative? It's a positive 152. All right, down the bottom, I get a positive 56x sub 2. Negative 7 times negative 9 is a positive 63x sub 3. And 13 times 7, I think, is 91. Yeah, and it turns out to be a positive. All right, let's add these two rows together. That goes away. 63 minus 144 gives me negative 81 x sub 3. And then on the other side, 243. So now what does my system look like? Now it's starting to look better, right? I got a 2x sub 1 plus x sub 2 plus 4x sub 3 equals negative 3. The second row gives me a negative 7x sub 2 minus 18x sub 3 equals 19. And the bottom row is negative 81 x sub 3 equals 243. Now, we're almost there. One of the simple things you can do is realize that 81 is actually a factor of 243. So just like you can multiply a row by something that's 3 or negative 2, you can multiply by negative 1 over 81, right? So you can do negative 1 over 81 row 3 and put the answer in row 3. So that'll give you an x sub 3 equals negative 3. And now technically at that point it's in its stair-step list. But if you want it in row echelon form, then technically we want coefficients of 1. So row echelon form, we want to have leading coefficients, because you can't have all of them be 1. So leading coefficients equal 1. So the leading coefficients are the ones that are in the front of the row. That guy, and that guy. So when I divide the first row by 2, I get x sub 1 plus 1 half x sub 2. 4 divided by 2 is 2, so I get 2x sub 3 equals negative 3 halves. The second row I divide through by negative 7, so it's going to look a little funny, but I'll get x sub 2 plus 18 over 7 x sub 3 equals negative 19 over 7. And so the third row simply gives me x sub 3 is negative 3. And there it is in row echelon form. It's in that stair-step pattern, and the leading coefficients are 1. Now, in a more practical sense, if you wanted to go back and back substitute with those coefficients that are integers, you could certainly do that, and nobody's going to yell. All right, so if I want to actually find a solution here, x sub 3 is equal to negative 3, done. How about the x sub 2? Well, x sub 2 plus 18 times negative 3 over 7 equals negative 19 over 7. If I add 54/7 to both sides, then I get x sub 2 equals 35 over, 35 over 7 is a nice whole number, right? 35 over 7 is 5. And so now go back to the top row, and I get x sub 1 plus a half of 5 plus 2 times negative 3 equals negative 3 halves. All right, so let's subtract a 5 halves from both sides. And negative 3 halves minus 5 halves will give me negative 8 halves. Negative 8 halves is negative 4. And now add a 6 to everything, and you get x sub 1 is 2. So if I want to do like I did before and write it in triple form, I get 2, 5, negative 3. Now I happen to know that this answer is correct, but when you're doing a system of equations like this, it's always a good idea to go back and check your answer to see if it's right. You could always take those numbers that you have for the solution, throw them back into the equation, and see if you really do get the same thing. And if you don't, if the equations don't match up, then you made a mistake somewhere, or there's no solution to the system. But if you came up with a solution, throw it back, and it doesn't work in all three equations, then something terrible happened. All right, let's try a couple more examples. They won't be nearly as long as this last one because now we have some idea where we're heading. But it's always good to take a look at a couple of more examples before we wrap things up for section 1. All right, so let's take a look at this system of equations. I've got 5x sub 1 minus 3x sub 2 plus 2x sub 3 is equal to 3. And eventually, we're going to work towards getting rid of all these variables in here and seeing if we can just represent the system with the coefficients. And that's where the matrices come in. So after a while, actually it won't be too long, we'll be getting rid of writing all these variables. And when we get the answer, we'll just know what they mean. All right, so I got 5x sub 1 minus 3x sub 2, 2x sub 3 equals 3, 2, 4, negative 1, 7, and 1, negative 11, 4, and 3. Those are all my coefficients. All right, so what can I do to solve this system? I'd like to get rid of those x sub 1s that are under the 5. So, right, I'm going to work my way down that first column to get zeros in the bottom corners. So if I take negative 2 times equation 3 and add it to equation 2, put the answer in the equation 3 spot. So if I take negative 2 times equation 3, here, can I cheat and just go, this will become a negative 2. Instead of a negative 11, this becomes a positive 22. And instead of a positive 4, this becomes a negative 8. And 3 times negative 2 is negative 6. Good. So now my system becomes 5x sub 1 minus 3x sub 2 plus 2x sub 3 equals 3. Middle row stays the same. And when I add the two of them together, 2 minus 2 is 0, so nothing goes in that bottom corner over here. 22 plus 4 is 26. So I got a 26x sub 2. Don't forget that's a negative 1. So negative 1 minus 8 is negative 9x sub 3. And then when I add a 7 and a negative 6, I get 1. Okay. Let's keep going. Let's try to get rid of that 2 that's in the x sub 1 spot. So over on the side, if I multiply negative 2 times equation 1 plus 5 times equation 2, put my answer in the equation 2 spot. So negative 2 times equation 1, and I'm going to do 5 times equation 2. All right, so this gives me a negative 10x sub 1 plus 6x sub 2 minus 4x sub 3 equals negative 6. And here I've got a 10, I got a 20, I got a negative 5, and I got a 35. You see I'm cheating and getting rid of those coefficients already. All right, add these things together. The x1s go away. I get a 26x sub 2 minus 9x sub 3 and a 29 over there. All right, we said this was going where? This was going in equation 2. So try to keep straight what's changing and what's not. Equation 1 is not changing. I got a 5x sub 1 minus 3x sub 2 plus 2x sub 3 is equal to 3. Here's what's going in for equation 2. 26x sub 2 minus 9x sub 3 is equal to 29. And we already have a 26x sub 2 minus 9x sub 3 is equal to 1. All right, something weird happens here. Suppose I were to take equations 2 and 3 and subtract them from each other. So suppose I took equation 2 minus equation 3 and put the answer in equation 3. So let's copy down that first row, right? The first row stays the same. 5x sub 1 minus 3x sub 2 plus 2x sub 3 is equal to 3. Equation 2 remains the same, right? Because if we're putting the answer in equation 3, equation 2 stays the same. But what happens when I subtract them? 26 minus 26 is 0, so I got nothing going over here. 9 minus 9 is also 0, so I just have a 0 on this side. And then 29 minus 1 is 28. Whoops. What does that mean when I get 0 equals 28? That means either I made a terrible mistake somewhere above, or that means that there's no solution. So if you get a crazy answer like that, what that means is that there's no solution. There's nothing that works where those planes intersect, right? Because we got 3 variables. Those things are planes. We don't have any place where those planes intersect. So no solution. That's what it looks like. Not any different from when you had a system of two equations and two unknowns. You got something crazy like 0 equals 28, and that just meant the lines didn't intersect, that they were parallel. Same thing happens in 3 dimensions. All right, one more example, and then this video is done. Suppose I have a system of like this. This is going to look a little different from the previous couple examples. So suppose I've got x sub 1 minus 2x sub 2 plus 5x sub 3 is equal to 2, and I've got 3x sub 1 plus 2x sub 2 minus x sub 3 equals negative 2. Now, the first thing I notice is I'm not going to get a standard answer like 2, 5, negative 3 or something like that, because I don't have enough equations. In order to get a consistent system, one that has at least one solution, I'm going to need as many variables as I have equations, or other way around. So in this case, I've got 3 variables, but only 2 equations. So I'm not going to come up with a consistent system. But still, can I describe a solution? All right, so let's start working our way through sort of like we had done before. Let's try to get rid of that 3 that's in the bottom left corner. So if I take negative 3 times equation 1, add it to equation 2, answer goes in equation 2. All right, so the first row I'm going to multiply by negative 3. And so that'll give me coefficients of negative 3, positive 6, negative 15, negative 6. All right, and the answer goes in equation 2. So equation 1 does not change. I still get x sub 1 minus 2x sub 2 plus 5x sub 3 is equal to 2. Now, when I take negative 3 and positive 3, that zeroes out. 6 plus 2 gives me 8. Negative 15 minus 1 gives me negative 16. And negative 6 minus 2 is negative 8. All right, once I see that, I go, oh, I can divide that bottom row by 8 right away and make life a little bit easier. So I end up with x sub 1 minus 2x sub 2 plus 5x sub 3 is equal to 2. Divide everything through by 8, and I get x sub 2 minus 2x sub 3 equals negative 1. All right, at this point, I need to get rid of one more variable. So what am I going to do? I'm going to get rid of the x sub 2 that's up here. So I'm going to sort of work my way back up towards the top. What I want to do is create a system that has at least one of the same variable in each one, so same x sub 2 or x sub 3, and my choice is I want to get rid of that x sub 2. So in order to do that, I'm going to take equation 1 and multiply equation 2 by 2, but this time I'm going to put the answer in equation 1. So what does that look like? Equation 1 is x sub 1 minus 2x sub 2 plus 5x sub 3 is equal to 2. Multiply the second equation by 2, and I get 2x sub 2. Multiply that by 2, and I get minus 4x sub 3. And then negative 1 times 2 is negative 2. I add these things together. I get x sub 1. The x2's go away. 5 minus 4 is 1. I'm leaving a space just to sort of line everything up. And 2 minus 2 is 0. Oh, okay. Let's rewrite then what that equation looks like. The first row becomes x sub 1 plus x sub 3 equals 0. The bottom row becomes x sub 2 minus 2x sub 3 equals negative 1. Now notice that they both have an x sub 3. So because they both have an x sub 3, I'm going to set up a parameter. And usually we use t as our parameter, and therefore my parameter will be that x sub 3 is equal to t. All right, now go back to that first row. If x sub 3 is t, then let's do some replacing. X sub 1 plus, well, in this case, t is equal to 0, which means that x sub 1 is equal to negative t. All right, go down to that third row. X sub 2 minus 2 times, again, I'm going to replace my x sub 3 with a t. and solve. So add a 2t to both sides, and I get x sub 2 equals 2t minus 1. So what is my solution? My solution is this. X sub 1 is equal to negative t. X sub 2 is equal to 2t minus 1. And x sub 3 is equal to t, where t is any real number. Does it work? Well, I mean, we could be silly and put a 0 in for t, right? In which case x sub 2 would be negative 1. Go back to my original equation. If x sub 2 is negative 1, negative 2 times negative 1 is 2. 8 times negative 1 is negative 8, and it works. Actually, you can go back to the first line, too. Play around with a little bit. I'm not going to go through every possible solution. It'd be impossible, but put a 1 in for t. Put a half in for t. Put a square root of 17 in for t, and it'll work. So what you're finding is not a specific set of values. You're finding out how the values are related to each other. That x sub 1 and x sub 3 are always opposites of each other, and the second variable is 2 times the third variable, subtract 1. All right, that's the end of section 1.1. Next video will be from 1.2.